Good day, guys. Darian Giuseppe here, back again with another video for the Key Concept series. In today's video, what we're going to look at is the last topic that we need to learn for Pure Maths Unit 2, where differentiation is concerned. So the last topic where differentiation is concerned, right? So this is the last key topic. It is partial differentiation. With regards to partial differentiation, the key is really to understand the notation, right? That's the real key. The notation and how you differentiate, right? You differentiate as normal, but it's a little bit different in the sense that we look at it, right? We look at it. So let's consider a function, right? If you have a function here, z is equal to f of x comma y, right? So there's a function, and they ask you to what will be tested or what could be tested in the exam is the first and second order partial derivatives, right? So that's the notations that we want to focus on in this video, right? The first partial derivative and the second partial derivative. So let's look at the first partial derivative. If we are given this function here and they ask us to find the first partial derivative for it, what is the notation, right? And the notation, as I said, is very key because the notation will tell you what you need to differentiate or how you need to differentiate, right? So this is the notation here. So we're looking at the first partial derivative with respect to x. And you have three different notations here. As you can see, this is really the common one, right? And you notice it is not written as a normal D, right? But it is a bent D, right? And that D is pronounced del. So therefore, this entire thing is called del z on del x. So that's how we say it, right? So that's very key as well. You want to make sure you're saying the proper thing in your mind, you're not saying the wrong thing, right? So it's del z on del x is how we pronounce it, right? And that is the first partial derivative, right, of z with respect to x. And what does that mean? It means that you see this guy in the bottom here, the x is considered the variable in this entire function, and the y is considered the constant, right? So once you know that, and that is in your mind, right? From the time you see this, the del, and you see x is in the denominator, you're thinking partial differentiation, and x is your variable, y is the constant, right? So you just differentiate as normal, right? Using all the differentiation rules, but just pay in mind you're treating y as a constant when you're differentiating. So an x would be considered as a variable. So you treat that as a variable when you are differentiating. So that's basically how you go about differentiating partial derivatives. So then the next first order partial derivative we have is del z on del y. That's the next one. So we had del z on del x, and we have to look at del z on del y. So when you look at this, del z on del y, that is basically what this is telling you. You differentiate partially. The del tells you that you differentiate partially. But then you look at the base partially with respect to what? Partially with respect to y. So y, when you're differentiating del z on del y, your y is considered the variable, and the x now is considered the constant. And you differentiate as normal, using the differentiation rules as normal. But you have to pay attention and keep in mind that your y is the variable. So you're differentiating y as a normal variable, as you would normally differentiate a variable, and x would be considered a constant. So you differentiate that considering it is a constant. So that's basically it. That's how you would go about it, right? So the key with first order partial derivatives, or not just first order partial derivatives, but partial derivatives in general, is for you to identify, once you see this del, you know it's partial derivatives. And then you look at the denominator, what you're looking to see which one of the variables would be considered a variable. If it would be x, if it would be y. And whichever one in the denominator is the variable, the other one or the other variable is considered a constant. That's basically it. So that's the first partial derivative. Now let's look at the second partial derivative. We actually have 4 second partial derivatives to look at. You could differentiate with respect to x twice, you could differentiate with respect to y twice, or you could differentiate with respect to x and then y, or you could differentiate with respect to y and then x. So let's look at the first two, which is differentiating with respect to x twice and then y twice. So second partial derivative, right? The first one we want to look at here is this, right? And this is really the key one that you want to focus on. This notation is really the key one. These are very important as well. You want to make sure, because you never know, they could bring it in the exam, and if you don't know it, you don't want to be lost, right? So these could come up as well, right, as your second derivatives. But this is the main guy that comes up, del 2z on del x squared. So that's just basically, you're still partial differentiating, right? Whichever is the variable in the denominator, that is the guy that is the variable. The other variable is considered a constant. So let's look at now the notation for differentiating y twice, or with respect to y twice, the function, right? So this is what we have here, right? It's basically the same thing, right? It's basically the same thing, but just wherever you had x, you had y, as you could see, and it's del 2z on del y squared, right? And that's basically it. You see this little equation here, that is just a breakdown of it. It just shows that you differentiate with respect to x here, and then you differentiating. It shows that whatever was a differential here is being differentiated with respect to x. Same thing here. Whatever was the differential here with respect to y, it is now being differentiated again. So that's basically what this is showing here. But it's really just 3, right? As you can see, 3 notations here. There's a whole one, 3 notations here. That's a whole one. So don't get confused by that. Pretty straightforward. So now let's look at differentiating x, then y, and then y, and then x. So the first one, right? You differentiate with respect to x, then you differentiate with respect to y. And be careful with the notation here, right? So this represents you differentiate with respect to x then y, and you can see it here as well, x then y. But look at this notation here. Look at it very carefully. You differentiate with respect to x first, and then you're differentiating that with respect to y. So that is very key, and you can see it here. It kind of in reverse order to this, right? X then y. So that is probably the order there, x then y. So just be mindful of that. And lastly, we have this guy, y then x. If we differentiate with respect to y then x, this is what we have here. So as I said before, you differentiate with respect to y first, and then you differentiate with respect to x. So y then x. It's kind of different. The order of this is a bit different to how we have it here. So just be mindful of that, right? Sometimes it confuses people. But as I said before, with regards to how you do your partial derivative, right? From the time you see this notation, the del notation, right? You're looking down in the denominator to see who you're differentiating with respect to. And that is the guy that would be considered the variable. The other variable would be considered to be constant, right? But you see the guy in the denominator, that guy in the denominator, when you differentiating partially, that guy in the denominator is considered the variable. All other variables are considered to be constants. So that's basically the key where partial derivatives is concerned. Something else that we notice with regards to partial derivatives is that you see these two guys here for the second partial derivative, they are usually the same. They are usually the same. And there's a little rule that we want to write down here and make note of where partial derivatives is concerned, right? So let me just write down the rule and we will talk a little bit about it. So this is the rule. The rule says that the partial derivatives, right? The partial derivative, and that is the second partial derivative we're looking at, right? The second partial derivative with respect to, you have x then y, and y then x, are equal if and only if both the function and the partial derivatives are constant. So both the function and the partial derivatives, right, are continuous. So that's the little note there. So that's very key, right? There's a little rule there. You want to make sure you understand and note, right? These are usually they are the same, right? And there's a rule governing them being the same. So that's basically it for today's video, guys. The key things where partial derivatives is concerned. Guys, I hope you understood this video. I hope you liked it. Guys, please like the video, subscribe to the channel, and tell a friend, share the video to a friend that you believe it can help who is doing Pure Maths Unit 2 exams in a not too distant future. And with that said, see you in the next video.